orthogonal trajectories. When the given family of curves are in the form of polar form, then how to calculate the orthogonal trajectories? The same procedure, but the equation containing r, theta and c is nothing but arbitrary constant. If the equation containing these three variables, you have to eliminate the arbitrary constant c value by doing differentiation with respect to theta. Then after eliminating the arbitrary constant, we get the differential equation f of r comma dr by d theta and theta equal to 0. Then replace dr by d theta by minus r square d theta by dr. This is perpendicular slope, like that we can calculate. Then you solve the differential equation. Then that answer means that family of one curve we will get it. That curve is which is orthogonal to the given family of curves. Now first question, find the orthogonal trajectories of r equal to a into 1 minus cos theta. This is the family of curves in polar form. Now given family of curves r equal to a into 1 minus cos theta, differentiating with respect to theta on both sides. Then dr by d theta equal to a into differentiation of 1 is 0, differentiation of cos theta is minus sin theta. Already minus is available, minus into minus it becomes plus. Therefore dr by d theta equal to a into sin theta. From this one we can calculate a value, a equal to 1 by sin theta dr by d theta. Then substitute this a value in the equation number 1, then like that we can eliminate the a value. R equal to 1 by sin theta into 1 minus cos theta into dr by d theta. I am rewriting this equation, r equal to 1 minus cos theta by sin theta dr by d theta. Now after eliminating arbitrary constant a, I got this differential equation. After getting this differential equation, you should replace dr by d theta by minus r square d theta by dr. Now I am replacing here r equal to 1 minus cos theta by sin theta. Instead of dr by d theta, I am writing here minus r square d theta by dr. Then r cancel. Then this can be written as 1 by r dr. I am separating the variables also here. Minus of 1 minus cos theta by sin theta d theta. Then I will convert this, I will cancel this 1. Then for that purpose I will write here, minus is outside, 1 minus cos theta. 1 minus cos theta means 1 minus 2 sin square theta by 2, because cos 2 theta formula is nothing but 1 minus 2 sin square theta, but here cos theta is available instead of 2 theta, theta is available. That is why we are writing in terms of theta by 2. Then once again I am writing here minus of 1 minus in bracket cos, instead of cos theta, 1 minus 2 sin square theta by 2 into d theta divided by sin theta also 2 sin theta by 2 cos theta by 2, because sin 2 theta formula is 2 sin theta cos theta. Now here minus 1 minus 1 cancel, minus into minus it becomes plus, minus of 2 sin square theta by 2 divided by 2 sin theta by 2 into cos theta by 2 into d theta. Then 2 cancel, 1 sin theta and 1 in place of numerator also we can cancel 1 sin theta by 2. Finally we are writing the answer here, integral 1 by r dr. I am integrating on both sides. Integral 1 by r dr equals to, that 2 is outside because minus sin theta by 2 cos theta by 2 is there. If you want to convert in the form of f dash of x by f of x, means in terms of log, that is why integration of 1 by r is log r. Then this is, I am writing outside 2 minus sin theta by 2 cos theta by 2 d theta plus c, 2 log of cos theta by 2 plus log c. Then that implies log r equal to 2 log cos theta by 2 into c. R equal to c into cos square theta by 2. This is the orthogonal trajectory of the given family of curves. this can be written as r equal to c into 1 plus cos theta also. This is equivalent to this equation. Otherwise, you can stop here, r equal to c into cos square theta by 2, which is orthogonal trajectory of the r equal to a into 1 minus cos theta. Second problem, find the orthogonal trajectories of the family of curves r power n sin n theta equals to a power n. Here a power n is the arbitrary constant, means a is the arbitrary constant. Now you eliminate a and you have to calculate orthogonal trajectory of this family of curves. Now solution, given family of curves r power n sin n theta equals to a power n. Now observe this equation, this equation containing powers n, means when you are doing differentiation directly it will be difficult. For that purpose I am applying logarithm, means when you are applying logarithm we will get that equation in simple manner. Then automatically after getting that form we will do the differentiation with respect to theta. Applying logarithm on both sides, log of r power n sin n theta equals to log a power n. Then log r power n sin n theta, we have two terms, log a into log b, log of a into b equal to log a plus log b. According to that formula I am writing here log r power n. Log r power n also again we can write n log r, because log a to the power of m equals to m log a. This is the basic formula, I am not writing here. Log a to the power of m equal to m log a. Using that formula I am writing here n log r plus log sin n theta equals to n log a. Now I wrote that given family of curves in this simple manner. Now you do the differentiation with respect to theta on both sides. Now differentiation of log r. Log r is 1 by r into dr by d theta. Now n is constant. Now when you are differentiating with respect to theta, n into 1 by r dr by d theta plus log of sin n theta 1 by sin n theta. Differentiation of sin n theta is cos n theta again into n equals to n log a is purely constant. When you are doing differentiation with respect to theta, it becomes 0. Now here cos n theta by sin n theta is nothing but cot n theta. Then I am writing here n is also I have taken common, I am sending that side, it becomes 0. Therefore 1 by r dr by d theta I am putting here only, and remaining terms you can send that side, minus cot n theta. Now after eliminating arbitrary constant a, I got the differential equation 1 by r dr by d theta equals to minus cot n theta. After getting this differential equation, you should replace the dr by d theta by minus r square d theta by dr. Now I am replacing here 1 by r, instead of dr by d theta I am writing here minus r square d theta by dr equals to minus cot n theta. Now r cancel, then it becomes minus r into d theta by dr equal to minus cot n theta. Minus cancel, again I am writing here, separate the variable, r terms one side and theta terms one side. 1 by r dr equal to, then this is cot n theta, you bring this side, then it becomes cot theta n theta, means 1 by cot n theta means tan n theta d theta, that implies integral 1 by r dr equals to integral tan n theta d theta. Integration of tan n theta is log of secant n theta by n plus log c. This is log r. Log r equals to 1 by n log secant n theta into c. Then this can be written as 1 by n, means you can send that side, log r to the power of n, n log r. I am writing directly log r to the power of n equal to secant n theta c. Therefore on cancellation of logarithm, r power n equal to c into secant n theta. This is the orthogonal trajectory of the given family of curves.